Hi everybody, in this video we're going to look at solving systems of equations in two variables. So let's start and I'll share my screen. So I have our title of our lecture here. At home you may also want to put the date in just to stay organized or make a note of which week of class that we're in when we're learning this. And we're going to get started. So we're only going to focus on linear equations here, so things that would be lines, and we're going to use just two variables. We're going to stick with the standard x and y, but of course you can use any variables you want, a and b, s and t, etc. It does get more complicated when you add more variables in. You're going to see that it's pretty standard that if we're trying to solve a system with two variables, x and y, we will have two equations that we're solving. So a system is when you have more than one equation that you're solving together. If we were solving something in three variables, let's say x, y, and z, then we would have three equations that we're solving together at the same time. So again, for this video, we're going to stick with just two variables. So you're going to see that our systems have two equations. And I'm going to give you an example to start, just so you can see what we're talking about. So here's one system in two variables. So you can see I'm using x's and y's here, and I have two equations. So again, a system contains more than one equation. And what's happening here is we want to find a solution that works in both cases. Okay, so it makes both equations true. And that's what it means to solve a system. So there's different ways that you can do this, and I'll show you a couple of different techniques in this video. The first strategy that you can use is graphing. And what happens is you'll find the solution at the intersection of the two graphs. Now, this method is most helpful when you have a nice clear intersection. So when your solutions are integer examples, it's not as helpful if your answers are fractions or decimals, because it's much harder to see that exact intersection point, but it's a good way to check your answers. So I like graphing for that visual check to make sure that we're on track here. But usually we tend to use either something called substitution or elimination to solve. So these are more your algebraic techniques. Now, there's also a way to solve using matrices. So if you've ever seen matrices before, you can do it that way. We're not going to touch on that last example in this video. We're just going to focus on the three sort of main, easier strategies for solving. Matrices are really helpful, particularly when you start getting into three variables or four variables or more than just two equations. So we'll hold off on that technique, and we're just going to do these three techniques in this video here. So I'm going to just walk you through the techniques with our example. So for graphing, the first thing I would do is I would just graph these two equations. And I'm going to go ahead and actually graph this first example by hand. And then I think I would just use a graphing tool for the others to save some time. So here are my two equations. I'm going to start by making an XY table for each and finding some points. And for a line, you just need at least 2 points. I like to just plug in points and solve. You can also solve using slope-intercept if you like instead, and putting in the y equals mx plus b form. That also works. So whatever technique you want to use to graph is perfectly fine. I'm going to start with this equation here. So one value I'm going to plug in is y equals 0. So when I do that, I get 3 times 0 equals 8. So this is going to cancel out. 2x equals 8, and dividing both sides by 2, I get my first point of 4. And then I'm going to go ahead and find another point. So here, let's use x equals 1. So 2 times 1 plus 3y equals 8. So 2 plus 3y equals 8. Subtract the 2 from both sides. 3y equals 6. And I have y equals 2. So I have the point here at 1, 2. Now, I did do a little bit of work ahead of time on this one, and I kind of thought through some points. If you plug in something, you get a fraction answer, that's perfectly fine. You can still graph fractions, you'll just have to estimate. It's obviously much easier to graph integers, so it may be helpful to kind of think through what values to plug in first to try to get those points. So I do recommend that if you can, but if you get fractions, it's okay as well. All right, so we have our first one. All right, so for this one here, I'm not going to work as hard. I'm going to let fractions be okay. If I plug in y equals 0, that's a pretty easy one. I just get x is equal to negative 1/2. And 1/2 is not too bad to graph, so I'm going to go with that one. And let's see here. Maybe if I plug in, we'll just plug in y equals 1. And I'm subtracting 6 from both sides. If you can do the math in your head, you can go ahead and do that. It ends up just being negative 6 and 1/2 because they're the same sign, so we can add them together. But if you want to do common denominators, you can. Negative 1/2 plus negative 12/2, which would be negative 13/2, which is also negative 6.5. So we're able to get our 2 points pretty quickly there. And here I decided to go with plugging in for y's because my x was already solved for. So again, I know I have fractions, but I found it just a little bit easier to go ahead and plug those in. So here are my 2 points. Now I'm going to move down. I'm going to graph those 2 points, and we're going to see where our lines intersect. And I think I'm just going to do my grid by ones. So 1, 2, 3, 4, 5, 6, 7, 8. I'm just putting a few marks in. Go down to negative 7 there. Okay, so my first line, and I'm going to use some different colors here, has the points 4, 0, and 1, 2. So there's 4, 0, and 1, 2. And I'm just going to do my best to use a straight edge here and graph that first line. And then for my second line, I'll use a different color. My points were negative 1/2, 0, so about right here. And then also negative 6/2, 1. So 4, 5, 6.5, and 1. See if I can get that line going here. And so about like this. So where those lines intersect would be my solution. Now here, I'm getting an intersection that is really not as clear as I would like it to be. It looks like maybe it's around 5 and negative 1/2. Excuse me, my allergies are bothering to me today. But it's not a nice clear intersection, right? If I cross that perfectly at like one of these little grid marks here, then I would be much more confident. So I'm kind of guessing it's going to be around 5, negative 1/2. But again, I'm really just guessing, and I do this by hand, so there's always room for human error there. So I have an idea of what I should get, but let's go to our next strategy. So graphing is a good start. It's a good check, but really Substitution and elimination are better strategies to be exact in your answer. So let's look at those two. So with substitution, what you're going to do is you're going to choose one equation to start and solve for one of the variables. Now, it doesn't matter which equation you choose to start, and it doesn't matter which variable you solve for. It's totally your choice. So usually I try to pick something that looks kind of easy. You know, you want to make your life a little bit easy here, but you choose whatever works for you. So I'm going to choose this equation because I don't really feel like dealing with that fraction right now. So I'm going to choose this equation to start with. And I'm going to solve for x because I kind of don't mind dividing by 2. I don't really want to have a denominator of 3. So I'm going to divide by 2. So I'm going to start by bringing my 3y to the other side. And then I'm going to go ahead and divide everything by 2. Now, when I divide by 2, remember you're dividing both parts. So it's -3/2 y, and then plus 8 divided by 2 is 4. So once you have that, you're going to substitute. Oops. Oh, there's my cat coming to say hi. Substitute the expression that you got here in the other equation. So my other equation that we didn't use was this one. And I'm going to substitute in. Now, just be careful. We solved for x. So I'm going to substitute in for x. So whatever the variable is that you solve for, that's the one you're going to replace. If I solved for y, then I would have replaced it with the y. So this is going to get plugged right in here instead. So it now becomes -3/2 y plus 4 plus 6y equals -1/2. And now we're going to go ahead and just solve this equation using regular solving techniques. Notice that you have one variable now, so you don't have to worry about dealing with 2 variables anymore, which is the goal here of substitution. Now, I don't really like fractions personally. I don't mind them. They're actually they're good, they're accurate. But when I'm solving equations, they're really messy to deal with. So I'm going to actually cancel it out. And I'm going to notice that my denominators are both 2. So if I multiply both sides by 2, then I'm able to kind of cancel that denominator out pretty quickly. Just be careful, you do have to distribute through. So you end up having 2 times -3/2 y plus 2 times 4 plus 2 times 6y equals 2 times -1/2. And you'll see that here, those denominators will now just cancel out. I'm going to keep combining like terms here. So on the left, I have, let's see, 9y plus 8 equals -1. I'm going to subtract 8 from both sides. And then I divide by 9, and I have y equals -1. Now, you don't always get a nice answer here, but we did in this case. So that's really good to see. So that's my y value, but I need my x value. So I have one more step. Plug your solution back into either equation to get the value for the other variable. So again, you could pick either equation here, it doesn't matter. I'm going to use that first one so I don't have to deal with fractions. Now here I had y equals -1, so I'm going to plug in for the y in my equation. I add 3 to both sides, divide by 2, and I have x equals 11 halves, or 5 1/2. So my solution here is 5 1/2, comma, -1. Now, if we look at our graph, we'll see we were pretty close. Here, I thought it was 5, maybe -1/2. So my drawing is obviously a little bit off. I drew it by hand. If I did it on a graphing utility, like a calculator or a Desmos, it'd probably be more accurate and you'd see that point a little clearer. Right? So I was a little off here, but I had a good estimate. So 5 1/2, -1 looks good. And if I had my drawing a little bit clearer, a little bit more accurate, maybe if I had a third or fourth point when I was graphing, I should see that exactly. Now, I'm not going to go through the full check here, but you can check your work. So what you would do is you would take both equations, excuse me, and plug in your solution. So when I plug in the first one, and then I plug in the second one, you should get true solutions. So I'll let you do out the math there, but you should get 8 equals 8, and you should get -1/2 equals -1/2. So you do get true statements in both cases. And it is a really good idea to get in the habit of checking if you can, just to make sure. I know when I was, when I practiced at home, I think I had the solution, then I realized I plugged it in and I made a silly mistake somewhere. So it will work in both equations when you are solving for a system. Okay, so the next method I want to show you guys, and I'm doing the same example so you can see that it works in all cases, is elimination. So this is elimination method. Now, usually in elimination method, we tend to write the two equations over each other. So we write them more vertically. And what you're going to do is you're going to multiply either one or both equations, it doesn't matter, by some number so that either the x's cancel or the y's cancel. Okay. So in this case, and sometimes you have more than one option. So notice here, what I could do is I could multiply the second equation by -2, because then I would have 2x and -2x, and those would cancel. I could also multiply the first equation by -2, because then I would have -6y and 6y, and that would cancel. So there's oftentimes more than one way to do it. So I'm going to go ahead and I'm going to multiply my second equation through by -2. And then I'm going to keep my first one the same here. Sometimes you may need to multiply both of them. If nothing easily cancels, you can always multiply both equations. And you can use different numbers there if you need to. Now, as I multiply the whole equation, so -2x, -12y, and then here -2 times -1/2 is +1. And then what you're going to do next is you add the equations. And I'm just going to do it up here. That's easy to see. One of your variables should cancel. You're left with -9y equals 9. And now what you're going to do is solve the resulting equation. So -9y equals 9, divide by -9, and I get y equals -1 again. Now your last step is the same as before. So you can go ahead and plug your solution into either equation to solve for the other variable. Okay, so we already did this, but I'll just run through it one more time. So I'm just choosing the first example here, the first equation. I'm going to plug in that -1. I get 2x minus 3 equals 8. I add 3 to both sides. I get 2x equals 11, and I divided by 2, and I got 11 halves, or 5 1/2. So I have the same solution here again. Don't forget, it's always x comma y, or whatever order the variables are given if you're using different letters like a and b or s and t or something. So you can write 5 halves, 11 halves, comma, -1. And you can do the same check. So if you need to, or if you're concerned about your answer, plug this answer into both equations and it will work in both and give you that nice true statement.